Hey there, math fans and pre-calculus fans. We're going to do a quick little note that's coming up related to a homework question. I have a homework question where students, if they've set it up correctly, they have an equation. They're having to solve for y, and then they're having to substitute in, and then when they expand, they're having to get it to a place where they have an r squared and an r. So the challenge the students are facing is to find what is here and what is here after doing all those operations. And what I'm sensing is that the challenge is I don't know what to do when there's a pi there. If there was a number there, maybe I could do that. But if there's a pi, I'm stuck. So I want to make a comment about working with pi or other constants. It really shouldn't change our solving in any way, but I've just noticed this over the years as a problem, so I just wanted to address it directly. So here on the right, you'll see I have solved this equation. And I find most students can do that. They would be happy if the final, if that all it was to solve this. But what they did, maybe without even realizing it, maybe just in a reflex, is you factored out the x. When you're combining like terms, you're actually factoring out the x. And you're saying, well, this is x times what? It's x times 2 plus 3. Now we do that so automatically, we don't even think about it. We just say 5x. But really, this is what you did. If you want to do it completely symbolically, this is what you did. And then we calculated. I mean, really, we should be able to replace all of these with random symbols and still be able to solve. If you want, we could do that right now. Let's do it. Let's replace all three of those with random symbols, and then we can solve for x. I find some people just take to this right away. Others, like, they don't get it if we use a different symbol. So let's have this be capital A. Let's have this be a lowercase e. And let's have this be a little person. Okay, so if those all represent numbers, we should be able to solve it the same way. This is going to be a plus e times x equals little person. And then we'll get x is little person divided by a plus e. That's it. So when it comes to solving, if you're treating a symbol as a number, it shouldn't change how we do things. So I am hypothesizing, based off of working with students, that this is the stumbling block. It's people think of it as with numbers, they can just immediately do it, and they don't think of it as factoring. Okay, so with that in mind, how would we solve this? We combine like terms. I don't think of it any differently, but I have a lot of experience here. That's what happens. That's just like doing 2x plus 3x is 5x. That's what I just did. But instead of saying 5, I said 2 plus pi, because that's the best I could do. And then you divide. So let me know if that helps anybody. I do think this is a stumbling block. On the final exam in Calculus 2 last term, there were all sorts of mistakes with a pi. I noticed. Okay, so let's go to the homework question. The homework question, the students have some equation. They have to get the y by itself. So let's see if we can do that. And I'll move this down because we might need more space. Okay, so what I would do if I'm trying to get the y by itself is I would move everything to the other side. So I'd have 2y is equal to 24 minus 2r minus pi r. Now you can just leave them separate and divide by 2, but let's just practice this thing I just said. Those r's should be able to go together, a negative 2 and a negative pi. So you can do it one of two ways. You do negative 2 minus pi and factor out the r. That's the same thing we're doing. So I think that's the biggest stumbling block. I might be wrong. I probably would pull out the negative, and then I would divide everything by 2. So this would be 24 divided by 2, minus, and then I'd probably write 2 plus pi, because I factored out the negative. Yeah, I'm doing some other little things here. If I solve that, that's what I would do. Okay. Then if I substitute in and I have to simplify, there's more of these challenges ahead. But I don't think they're that big of challenges. So now I would like to simplify this area formula, which is 2r times 12 minus 2 plus pi over 2r plus 1/2 pi. And for my students, you're immediately done once you know the coefficients of r squared and r. So you're going to expand this thing, and you get 24r. So I already have the coefficient of r. I did this times this. And I'm going to multiply the other one. Now that 2 and that 2 will cancel. You'll get better at seeing these things the more you do this. So all that will be left is this and this. We can factor out an r squared. Once again, this same skill. 24r. And let's put all this together, all inside one big parenthesis. So I have this negative thing, the -2, the negative pi, and I have the plus pi. Excuse me. So then we can combine that all together. 24r. There's not much else I can simplify. You could leave it like this. I think negative pi and positive pi. I'm going to do a fraction thing, and then everyone's going to have a question. Good part on the video is nobody can ask me a question. Okay, so here's V, here's A. And if you wanted to find the vertex, you could find it. I just want to do a little thing about the reason that looks bad is because the pi, but actually I think the confusion, and please correct me if I'm wrong for those of you, if anybody in the world watches this video, I think the confusion is this thing, this understanding that this is 2 plus pi times x, and that's actually doing the exact same thing as when it's 2x plus 3x. So I think it's a factoring thing that's causing the problem. There are other issues, but I hope that sort of helps for that one specific thing.